So before our programs start to get any longer, it's important that we learn this concept of breaking a program down into functions. What functions do is that they allow us to break down our program into smaller, more manageable chunks. How exactly do they do that, you might ask? Well, basically a function lets us write a whole program and lets us give that program a name so that we can use it wherever we want. Now, the next time I want to use that program, I just use its name. And it becomes a one-line statement and it refers to this huge block of code. And so the benefit of that is, let's say I am making a program and at many different parts inside that one program, I want to take input from the user 5 times and I want to add them up. So I'd write the code for this program and then I'd name it something like sum5. And so the next time I want to do this, I would just do sum5 and then empty brackets. Now, this type of statement might seem a bit familiar to you. As a passing comment, when we were studying about variables and algorithms, we talked about functions that we were using inside our chai program. For example, no bubbles, heat, lower flame, and all these had brackets afterwards, but most of them had a variable inside them like pot. These were all still functions. And basically, they were doing a lot of work for us, but in the middle of our program, we weren't defining each of the steps. We were just saying, hey, do this function, and this function probably has a bunch of steps, but they're being done separately. And we've encountered many functions. For example, print is a function, input is a function, and you notice that the common way of writing it is there's a name and there's brackets after it. And sometimes these brackets have something inside, sometimes they're empty, depending on the use. Oh yeah, type is also another function. And the way we call it is we write type, and then inside of the brackets, we write in the data value that we're trying to use. Whatever goes inside the function is called the argument, and it helps our program decide how to run. But what's the point of functions? Why would you want to break down your code? Just write it once and get it over with. There are many uses for that, but one very major use is that you can reuse it at different places. For example, as you go deeper into programming, you're going to be encountering libraries and modules. What a module does is that it expands the functionality of your program. So like you already have a set of functions available to you by Python, but then you can have a lot more. For example, there's this library called maths, and basically this gives me access to functions like maths.log10. Now what maths.log10 does is that it takes in an input, for example 1000, and returns its value to the base log10. And so in this case it'll be 3. It also gives me access to very useful values like maths.pi, and even has a specific square root function called maths.squareroot. We have maths.sine, and then we pass in a value in radians, for example 1, and it gives us the sine value at 1 radian. And so by breaking your program down into functions, you can then reuse those functions in other places, which is very handy. Now, on the topic of the maths library and maths functions, if there's anything that you want to do that involves math, but you can't seem to find any inbuilt Python functions for it, you can check if the math library has any related functions. To do that, just Google Python math library functions, and you'll find this docs.python.org. This is the documentation for the Python math library. And you can go in here and you'll see a bunch of different functions. I recommend just reading this once so that you have an idea of what all already exists, and that way, if you ever need anything for a program, you at least know that a similar function exists and you can look it up and understand how it works. For example, if I want to do LCM, instead of making my own formula, I can use the maths.lcm function. But don't become completely reliant on the maths library. It makes for good problem solving practice when you take these inbuilt functions and try to come up with your own versions of them. Okay, so that's cool and all, but how do we write our own function? And to demonstrate this, I'm going to write a function that takes in an input of two numbers and then prints their sum. So the syntax for that is that you write def, which is short for define, then you write the function name, for example, sum2, then you add brackets. Now inside the brackets, you can specify parameters or arguments. For example, if I was getting the input of the numbers I want to add from outside the function, I would do num1 comma num2. But in this case, I want to input it inside the function, so I have no parameters I really need for that. Then I'll add a colon. After that, we're going to move to the next line. And what you'll notice here is that Python automatically is giving me a gap. This gap is the equivalent of 4 spaces or 1 tab. But basically any code that's inside of this function has to be written slightly indented like this. Now the process is straightforward. We're just writing a program. So how would I normally write it? I'd create a variable num1 and I'd assign it the input. Then I'd create a variable num2 and assign it the input. In case you're wondering why I'm not emptying num1 and num2 beforehand, because again, when computer gives us memory, it's not necessarily empty. Whatever I get from input is going to override it anyways, so I don't have to worry about that. While we're at it, I should also put these inside an int statement. And next up, I just have to print the sum. And so I go ahead and run the program and nothing happens. The program ends. Why? Well, the thing is, when you write your function's code, your function is not automatically going to run. It's only going to be run when it's called. So what I'll have to do is I'll have to go outside this function by unindenting. And I'll have to type in the call statement, which will be sum2 with empty brackets. And that's going to call this function. So now it's going to ask me for input. Now, this was bad practice. I should probably have like words inside of these statements. Okay, so let's run this again. It's asking me for a number, so let's add 6, and let's add 10, and it gives us 16. And so now every time I want to do this, I can just go ahead and copy this line over, and then 5 and 10, 20 and 30, 17 and 81. And it's going to do this 6 times over because I've called the function 6 times. And this way we've written our own function. Now this type of function is called a fruitless function. And that's because whatever happens inside the program isn't really coming back to me. Whatever the value of the sum is, I'm just outputting it. I'm not storing it anywhere. If instead I wanted to store it, what I can do is instead of using this print statement, I can write this return statement. What return does is that it takes the value of the sum and sends it back where the function was being called. So now if I were to run this program and I were to add like 10 and 5, it does nothing. Well, why? Well, what the return does is that it literally just replaces sum2 with the value that's being returned. So in this case, sum2 is just getting replaced by 10 plus 5, which, yes, that evaluates to 15, but if you're working in Python script mode, if it's not inside a print statement, you're not going to see it. And if it's not being assigned to anything, it's just lost forever. So one solution is we can store this in A, but we want to see what's inside of A afterwards, just so that we can confirm that it was stored in A in the first place. So let's try this again, 10 and 5, and there we go, it's being output. Alternatively, I can just put sum2 inside of the print statement, and that'll do the same thing for me. So great, we've learned about fruitful functions and fruitless functions. Fruitful being the ones which return, and fruitless being the one that just do their own thing without affecting the rest of the program. Also, let's try something. So let's make sum2 a fruitless function and still try to print it. So let's see what happens. So we put in 10, we put in 5. It gives us 15 and it gives us none. So what's happening here? Well, basically, when sum2 is called, it's going to execute all of these statements, and then it's going to print the sum, which gave us 15. Now, functions which don't have an explicit return statement, it's kind of like it returns none at the end of the function. And so that's what's happening. Sum2 just becomes none, and so we're just printing none. And the reason why the program has to have that none statement at the end is so that it knows that, hey, the function's ended, go back to where I was called from. Also, if we were to print sum2 without the brackets, that just writes this statement, and that says that sum2 is a function object, and we can confirm that by putting sum2 in a type statement, and it will say that it is a function. Okay, so I've set my function to be a fruitful function, and the next thing that we're going to explore is the flow of execution. So what I'm going to do is I'm going to start debugging my program, and I've added a print hello statement just to like start our debugging, and it's going to start me off here. Now, currently the program's at print hello. I move one step forward, it outputs hello, and it comes to this line. Now this line has a function sum2, and so when I step into this program, it's going to take me to the function's definition. Now num1 is going to ask me for input, 50, then I have to go through this line. Now num2 is asking me for input, so I say 20. Now it goes to this line. It's going to add num1, which is 50, add num2, which is 20, and it's going to return, which means it's going to bring it back here. And so once we press this step into, it's going to take us back to the print statement. And once we step through the print statement, since this now has a value of 70, this is the return value, it's going to print 70 and it's going to output. Now next up, we're going to cover the idea of parameters and arguments and what's the difference between them. So I've changed my function into one that takes in arguments, and basically arguments means the numbers that are entered here, or not necessarily numbers, just any values which are entered inside the brackets. These are the arguments. Also, you can get creative with it. The input of a function can be another function or an expression like this. And what's going to happen is these arguments are going to get assigned to num1 and num2 respectively. So that means 13 gets stored in num1, 23 gets stored in num2. And we can verify that by doing print num1 and then print num2. And when we're going to run the program, it's going to go ahead and print 13 and then print 23, 13 being num1 and 23 being num2. To better understand what's happening here, you can also write it as num1 equals 13 and num2 equals 23. Now this shows you that whatever value you're putting here, that's getting assigned to the first parameter, whatever value you're putting here gets assigned to the second parameter. And this way of understanding is useful because of a thing called variable scopes. Now what exactly does that mean? Let's say I had a num1 over here and that is 20, and I had a num2 over here and that is 10. This num1 and num2 are separate from this num1 and num2, but I can still pass these as arguments. So if I write my statement like this, it's like me saying take 20, which is the value of num1, store it in num1, which is the parameter. Take num2, the argument, take its value, which is 10, and then store it in the parameter num2 of the function. And so when I print it, it's going to print 20, 10, and then 30. 20 for num1, which it got from the argument, 10 for num2, which it also got from the argument, and 30 being its return statement. What's important to note is if I were to switch around the positions of the arguments, now what's going to happen is that num2 is going to get stored in num1, and num1 is going to get stored in num2. And to make that clear, I'm just going to add a string which says 1 colon and a string on this line which says 2 colon. And once we press print, we're going to see that the value 10, which was in num2, is being assigned to the first number. We see that the value 20, which was assigned to num1, is being printed next to 2, which means that num1 is actually getting stored in the parameter num2. And the argument num2 is being stored in the parameter num1. Another interesting thing about Python is that this is a valid way of passing parameters. And what I mean by that is that even if I have the equals to sign, if I run the function, it's going to give me the output I expect because num2's value, which is 10, is getting stored in num1 that's being printed first. Or I can change around. I can say num2 equals num2 and num1 equals num1. This is very painful to read, but essentially the parameter num1 is getting the value from the argument num1. The parameter num2 is getting the value from the argument num2. And so now it's going to print it in the correct order. And there we go. The value 20 is getting stored output with 1. The value 10 is being output with 2. What's important to note here is that in Python, if you don't use the equals to sign, then it's just going to pass the first argument into the first parameter. But if you use the equals to sign, you can explicitly tell which parameter to store this value in. But most of the time, you're not going to be using the equals to format. But it's important to have that running at the back of your head because sometimes what will happen is you'll have variable names in your function and you'll have similar variables in the main program, and they're both going to be referring to different things. For example, num1 in the main program refers to num2 in the function. Another interesting thing to note is that if I were to print num1 at the end of this, the value of num1 in the function was 10 and the value of num1 in the main program was 20. So which value do you think is going to be output? Well, the output value was 20 because this value of num1 and num2 is local to this function. Only inside of this function, if I were to say print num1, does it actually print 10, as you can see on this line here. Now this num1 and this num2 are local variables, whereas these variables, num1 and num2, which are inside the main program, outside of any function, these are global variables. They can technically be accessed from our functions if I were to add a global num1 statement, but because of the same name types, it's not really letting me do it. If instead my variable was called num and I did global num, then now I can access the num variable from inside the function. And I know num has the value of 20. And so there we go, my program's printing 20 again. Another way of understanding what's happening is by the use of a stack diagram. So the main chunk of the program which we had was main, and it had its variables. In our case, it was num and num2 with their respective values, so 20 and 10. Then our function sum2 had values num1 and num2, and they had the values flipped around, so 10 and 20. So this num1 and num2 are variables of sum2, and this num and num2 are variables of the main program, and they're stored separately. This type of demonstration of a function is known as a stack diagram, and it shows each function call as a separate box or a frame, and shows the state of each local variable inside that function. And that's about it for functions, at least for now. But now that we understand what functions are, we might still be left with that one question. Why? It's a bit difficult to understand that right at the start. I know it took me a while to realize why they were useful. But functions teach you how to break down your program into more easily readable and debuggable chunks. And if you make use of good functions, your Python program basically reads like English. Functions also help you when you're trying to do the same or similar tasks over and over again. One example I have is one time I was trying to make a game of tic-tac-toe, and so in that I had to check if there was a horizontal line, a vertical line, or a diagonal of same symbols. And so while I don't remember the exact code I did, I know I somehow made it so that I would check 3 cells, and I just called that function 4 different times for the 4 different possible lines. And for each of the different lines, I just had to slightly change the arguments. And lastly, a good function is very reusable, even in other projects. And again, just like with every chapter, there's going to be a lot of bugs. But that's fine. And the process of debugging, while somewhat painful, is also kind of fun. Just think of all the possibilities where you think an error could have occurred, and for like maybe each chunk of the program, add a print statement to find exactly where the error did occur. And this way of just narrowing down where the error is and what the error is kind of fun. It is hard work, but it's really rewarding at the end. And so now that you understand how functions work and are hopefully ready to take on the task of debugging them, it's time for you to try at the end of the chapter exercises. Small little side note, if you want to print the same thing on multiple lines, you can make use of a print statement, and so that print statement would have your pattern, and then you're going to add a string of \n at the end. And what \n does is it takes you to the next line. And then you're going to take this whole string and then you'll multiply it by the amount of times you want to change lines. So for example, if you wanted to repeat this pattern across 4 different lines, you just add 4 here and you'll end the print statement there. So yeah, to print multiple lines of the same type, you take your string, you add \n, which takes you to the next line, and then you multiply that by the amount of lines you want to do this for. That's it from my side. Happy programming.